So there are two ways to do this problem. The first one is what I would call the algebraic approach. And I'll just label the length as L, width as W. We're told that the length is increased by 20%. So that means the new length would be 1.2L because it's really L plus 20% of L. And that's 0.2L. And that becomes 1.2L. So I recommend that you're comfortable doing this in one shot. So our new rectangle would look something like that. Length is 1.2L. And we want to know what happens to this new width. So the condition is the area remains the same, which means area here is L times W. And for this new rectangle would be 1.2L times W new. You'll notice the L drops out. So we're told that the new width is the original width divided by 1.2. So the percent change would be original, and that change would be W minus W new, which would be W minus W over 1.2. And we always, to find the percent change, you always divide by the original. Now this is already, will be positive because I'm subtracting it this way, but it is a decrease. And so I just have to simplify this. The W's will drop out. It's going to be 1 minus 1 over 1.2 times 100. And then we can write this as 1.2 minus 1 over 1.2 times 100, or 0.2 over 1.2. You can use a calculator at this point. Sixth. So it's really 1/6, which in percentage is 16 2/3%. Some of you might already know this. But if you use the calculator, you'll get 0.1666, so on. And then if you multiply by 100, would be 16.666. So that's one approach. The other is you can select numbers. For example, you could say the original length is 10, and let's say the width is 8. So the new length goes up by 20%. 20% of 10 is 2, so that would be 12. So original area is 8 times 10. New area would be 12 times W, so we can find the width, the new width. Again, you can use a calculator here, 20 over 3. So the question is, what's the percent change? So again, 8 minus 20 over 3 divided by 8 times 100, and that becomes 4/3. And again, this would be 1/6 and comes out to be 16 2/3. So the answer is B.